Hello, my name is Michael Schmid, and I am the president of Micro Nanotechnologies, otherwise known as MNT. Today, I'd like to discuss MNT's technologies used in the creation of an energy-efficient, reversible replenishment air conditioning system for naval ships and other applications. This development work is being carried out under a Navy SBIR Phase 2 contract for Topic N231-063, sponsored by ONR Code 331. As we begin, please allow me to give you a very brief introduction of MNT. MNT, located at the University of Florida's Innovation Hub in Gainesville, Florida, was founded in 2013 by Dr. Saeed Moghadam, a UF mechanical engineering professor, to facilitate the commercialization of industry-changing heating, cooling, dehumidification, and drying solutions based on high-throughput functional membranes. MNT has received state and federal funding in the form of full and open grants and SBIR Phase 1 and 2 awards to assist in the commercialization of its air conditioning technology designed specifically to efficiently handle hot and humid air for ventilation air conditioning, dehumidification, industrial drying, and atmospheric water capture. As a result of this funding, MNT is currently field testing an atmospheric water capture system in a remote desert location and will start field testing two systems, one for an industrial lumber drying and one for a ventilation and air conditioning or HVAC application in late 2025. Working in collaboration with industry OEM partners, this field testing represents a significant step in the commercialization of this technology. Our cooling technology, experimentally shown to handle heat loads approaching 2,000 watts per square centimeter, can efficiently provide the cooling necessary for the next generation of chips, computers, data centers, and high heat load applications. MNT is working with several partners to field test this technology in high-performance data centers in early 2026. HVAC systems are critical to the effective operation of modern naval vessels, ensuring the health and comfort of the crew and the functionality of the ship's combat and control systems. Naval ships, similar to commercial buildings, are required to provide 20% of outdoor replenishment or ventilation air. Given the high humidity loads typical of maritime climates, shipboard HVAC systems consume a significant amount of energy dehumidifying this ventilation air, typically 10 to 20% of the total cooling load during summer. This represents the second highest cooling load within the ship. This is due to the operating principle of current HVAC systems that need to subcool the air to remove moisture by condensation on cooling coils. In the winter season, shipboard HVAC systems use electric heaters to heat the incoming ventilation air, creating a significant electrical demand. These ventilation systems are used to supply ventilation air to multiple recirculation air systems. In these recirculation systems, the conditioned ventilation air provided by the ventilation system is combined with the recirculation return air before it is cooled and distributed within the ship. Evolving battlespace doctrine, emphasizing operations in both the littoral and Arctic, as well as changing climate conditions, are further increasing these loads. As such, there is a significant need to reduce the ventilation latent load and improve efficiency, while reducing the size, weight, and electrical power consumption of shipboard HVAC systems. In this program, a working prototype of a 2,000 cubic feet per minute ventilation system using new technology will be developed and experimentally tested to demonstrate its ability to reduce the ventilation latent load and improve shipboard HVAC system efficiency. This prototype, sized for 10 tons of cooling when exposed to summer design conditions and 30 kilowatts of heat when exposed to winter design conditions, will experimentally validate the system's performance over a variety of airflow rates and inlet conditions at design and off-design conditions. In addition to these performance tests, supporting analysis and mechanical testing will be conducted to demonstrate the viability of this technology to operate in the naval environment. A liquid desiccant ventilation system based on MNT's technology is being scaled to address the Navy's requirements. This system will remove water directly from the ventilation air as a vapor. eliminating the need to subcool the air to remove moisture by condensation. The liquid desiccant will be regenerated using waste heat, with the system being cooled using seawater. This removes the entire ventilation system load from the ship's HVAC chilled water system. Additionally, the use of an intercooled absorber provides the ability to independently control the exit air humidity and temperature conditions, increasing system functionality and flexibility. The system is designed to enable the deep dehumidification of the ventilation air, such that when combined with the return air in the recirculatory system, the latent load within the recirculatory cooling system can be eliminated. This provides the ability to potentially operate the recirculation system cooling coils as dry coils, further decreasing the HVAC system load and improving system reliability. Based on the program's Phase 1 analysis, this system has the potential to reduce the shipboard HVAC load by greater than 25%. The key features of MNT's technology are a novel semi-open architecture, a non-crystallizing, non-toxic ionic liquid desiccant, an integrated desorber condenser module, a membrane-based modular absorber, and the efficient recovery of heat to improve system efficiency. MNT's semi-open cycle provides an efficient, simple architecture operating at atmospheric pressure without the need for secondary scavenging or exhaust airflows. This simplifies the integration of this design within the ship. The favorable crystallization characteristics of ionic liquids enable the operation of absorption cycles at temperatures, efficiencies, and configurations not obtainable with the conventional desiccants, greatly simplify the system's operational controls and supporting its integration with the overall shipboard HVAC system. The integrated multiplate modular desorber and condenser provide the ability to scale capacity to meet demand in a small and compact form factor. The desorber is waste heat driven, and the condenser is seawater cooled, removing these loads from the shipboard HVAC chilled water systems. The intercooled multiplate absorber provides a large surface area with minimal pressure drop to support the dehumidification of the ventilation airstream. A thin film of ionic liquid, constrained by hydrophobic membranes permeable to water vapor, flows across the outer surfaces of each absorber plate. As the water vapor is absorbed by the ionic liquid, the heat released is absorbed into cooling water within each plate. This immediate removal of the heat increases the system dehumidification performance, and depending on the cooling water temperature and flow rate, provides the ability to cool the ventilation air. Our lab and field performance testing has demonstrated the ability to efficiently recover and reuse approximately 95% of the heat used within the system. This significantly improved the system's capacity and performance. These features enable a technology capable of efficiently handling the ventilation air latent load and providing the ability to independently control the ventilation air humidity and temperature exit conditions. MNT has developed the core technologies used in this system, experimentally tested them in a lab setting across a wide range of inlet air dew point conditions, and developed a set of validated simulation models to support the system's scale-up and design. These validated models were used in our Phase 1 effort to establish the feasibility of this system to meet the Navy ventilation air requirements. Additionally, MNT has developed and proven a set of production processes enabling low-rate production. These production processes have been used to fabricate the set of systems to support our current and planned field testing efforts. Building on the lessons learned from these activities and the unique requirements of the naval environment, we are currently developing a 2,000 cubic feet per minute ventilation system prototype. This system, supported by the relevant hazard and reliability and maintainability analysis, will undergo performance testing across design and off-design inlet air conditions by a recognized third party. In the future, upon the conclusion of this performance testing, the system will undergo naval shock and vibration testing to ensure its ability to operate within the naval environment. Subsequently, we will start the certification and qualification process required for HVAC systems, with the ultimate desire the installation and testing the system in a U.S. Navy ventilation system. With the completion of our Phase 2 effort, Additional testing in U.S. Navy facilities will be required prior to the use of this technology in future Navy ships. Coordination will be required with existing HVAC system suppliers and Navy shipbuilders such as HII and General Dynamics to ensure its proper integration into these new designs. Additionally, the certification, market entry, and use of this technology in commercial and industrial applications will serve to provide more data, performance, reliability, etc. regarding the viability of this technology. Thank you for taking the time to listen to this presentation today. We hope this presentation has been a useful introduction to MNT's dehumidification technology and its potential application in naval ships. As this technology is applicable to a variety of applications, including hospitals, buildings, hangars, and others, in which humidity control is important or critical, please contact us to discuss your application. Finally, if you are interested in our other technologies, please contact us or visit our website at www.mntusa.com.